Hello, ladies and gentlemen. Welcome back to Chapter 9, where we have been talking about moles and stoichiometry. Okay, so far we have done a bunch of different things, and we are going to continue today with stoichiometry Part 2. Now, before we add new information, I want to review a bunch of the different things that you have done so that you realize you have learned all these different things and so that you can have them in one place. Okay, first off, what you learned was how to figure out how many atoms in a mole. Okay, atoms to moles, or moles to atoms, sorry. Okay, so you started out with a certain number of moles. You have this ratio, Avogadro's number per mole, and you ended up with a certain number of atoms. Okay, then you were trying to figure out the mass of a certain number of moles. You started out with the moles. You had 1 mole and you did the molar mass, and then you figured out the number of grams. Remember, the molar mass is just how many grams in a mole. So you have 1 of helium, 4.003, 4.003. Then we took a jump and we went from grams to atoms, with remembering that moles must be in the middle of this. You can't just go straight from grams to atoms. You have to go grams to moles to atoms. And we started out with a certain number of grams, 0.4 grams. We used the molar mass right here, 12.001 for carbon, and then we went from the moles to the atoms. Okay, so grams to moles, remember grams cancel out, then from moles, which cancel out, to atoms. Okay, then we switched it around and went from atoms to moles to grams. Again, moles in the middle. So we started with a certain number of atoms. You used the atomic ratio here for a mole, Avogadro's number in 1 mole. That's the same number no matter what substance. It's always that number per mole. And then remember, atoms cross out, so you're moles of carbon. And then you have the molar mass right here where you subtract, or you cancel out the moles and you're left with grams. And again, please be reasonable in the number that you leave. Do not leave me this long thing. Okay, then we went from moles to moles and everybody's head exploded apparently. Okay, all we are really doing with this is comparing these coefficients at the beginning of the equation compounds to see how they're related to each other. Okay, we created a mole ratio, which is just a comparison of these. Okay, so for what it means is for every 1 P4, you have 5 O2s. If you want to go crazy, for every 1 P4, you have 2 P2O5s. Okay, or for every 5 O2s, you have 2 P2O5s. That's the molar ratio. Okay, and if you want mole to mole, if you have moles of P4 right here, that's the amount that it tells you to start with. Okay. You then have the molar ratio right here, and then you get your answer. Okay, this is the second part. Figuring out O2. We already figured out P4 and P2O5 in the first part. That's how we got this number. I didn't put all the slides. Okay, but the key, remember, is you go from moles to mole ratio. Moles of this cancel out, moles of this cancel out, and you are left with moles of the other substance. Okay, and you can see the 5 to 1 right here. Moles of P4 on top, moles of P4 on bottom, so that they'll cross off and cancel out. Okay, hopefully you get this. If not, we need to talk some more. But the key to remember is moles in the middle. Okay, in all of this, whatever we're doing, you go from whatever it is to moles. If you need to go somewhere else, you go from moles to that. Okay, make sure that you don't forget that, and don't forget the basic formulas and numbers. You can go look if you need to. Okay, now what we're going to do next is really just a blending of two of these. So don't panic, you know the steps already. We are now going to go from mass to moles of one substance to moles of another substance. So we have the same equation right here. Okay, and the question says how many moles of P2O5 can be formed from 300 grams of P4? So you're going to start out with your number of grams, the mass. You are then going to use a comparison with the molar mass right here, and grams is going to cancel out, and then you're going to get moles of your first substance. Okay, so you start out with your 300 grams of P4. Now, you have to figure out the molar mass. Remember that you do that by looking at the periodic chart. Now, this thing we want a molar mass of is P4, not just P. So P right here gives us 30.974, but we need to multiply that times 4 because there are 4 of them. So what you get is for every 1 mole of P4, you get 123.896 grams of P4. That's multiplying the mass of 1 phosphorus times 4 because there are 4 of them. Okay, grams and grams are going to cancel out, and you then figure out you have 2.421 moles of P4. Okay, so we've gone from mass, 300 grams of P4, to moles of P4. That means if we have 300 grams of it, we have this many moles of it. Okay, but that's not the end. We want to know how many moles of P2O5 can be made. Okay, so we take the next step. Okay, we are talking about the number of moles that we know, which is the number of moles of P4. We're going to use the mole ratio, and then we're going to get the moles of unknown. Okay, so mole ratio, we come and we look at these two numbers because those are the two we're comparing. So we're looking at 1 P4 for every 2 P2O5. So our mole ratio is 1 to 2. So you simply write that mole ratio in. Now, you remember to have it the right direction. P4 over here is on top, so P4 goes on the bottom. For every 1 mole of this, you have 2 moles of this. Okay? You then simply plug your numbers in. So it's basically 2.421 times 2. The moles of P4 will cancel out, and you will get the delightful answer of 4.842 moles of P2O5. Okay, so you go from mass, the number of grams, to moles, in this case of P4, and then from the moles of P4 to the moles of P2O5. Okay, hopefully all of this is making more sense as you practice. And I know you can get it, so don't give up. I know it looks confusing. I know it can be confusing. I cringed at the thought of teaching this online with you because I know it's confusing. But just take it step by step, think about what you're doing, and you will get it. Don't worry.